Hello, smart mathematicians. Let's do question 11a. Prove the following identity. We have the left-hand side and the right-hand side. Right, we can start with the left-hand side, the one which looks more complicated. So we can change sine 2x. Remember the double angle formula. Let's do that. And then we change that to 1 plus 2 sine x cos x. Right, we're changing this. And then plus sine squared x minus cos squared x. All this over 1 plus 2 sine x cos x plus, and then cos 2x is also double angle formula. Remember that cos 2x is equivalent to cos squared x minus sine squared x. Right, this is equal to tan x. Right, there are two ways we can deal with this. We have to remember that 1 is equivalent to cos squared x plus sine squared x. So we can change these two and replace them with cos squared x plus sine squared x. Let's do that. Cos squared x plus sine squared x. This is equivalent to 1. Then plus 2 sine x cos x. This is just the same. Then plus sine squared x minus cos squared x. And then all this over, we replace this with cos squared x plus sine squared x, cos squared x plus sine squared x, and then plus, we have this 2 sine x cos x plus, and then we have cos squared x. Even if you remove the bracket, the signs of the terms inside the bracket do not change because of positive 1 outside the bracket. So it's still cos squared x minus sine squared x is equal to tan x. Right. Cos squared x minus cos squared x is 0. Then sine squared x minus sine squared x is 0. Okay. And then we're left with sine squared x plus sine squared x, which is 2 sine squared x and plus 2 sine x cos x. That's the numerator. And then cos squared x plus cos squared x, that is 2 cos squared x and plus 2 sine x cos x is equal to tan x. Right. And then here we have the highest common factor. We can factor out 2 sine x. We can factor out 2 sine x. 2 sine x, and then 2 sine squared x divided by 2 sine x. This is sine x. And then 2 sine x cos x divided by 2 sine x. That is cos x. Alright, and then we have, here we can factor out 2 cos x. 2 cos x. And then 2 cos squared x divided by 2 cos x. We remain with cos x. 2 sine x cos x divided by 2 cos x, we get what? We get sine x. Right. These two are just the same. Remember, addition is commutative. So sine x plus cos x is just the same as cos x plus sine x. So we can say this bracket divided by this bracket, we remain with 1. Right. And then we have the left hand side, the right hand side. Right, we have 2 sine x, 2 cos x is equal to tan x. 2 divided by 2, 2 divided by 2 is 1. We remain with sine x over cos x, which is tan x is equal to tan x. Then left hand side is equal to right hand side. We have proved that the left hand side is equal to right hand side. Okay, and then we can do things differently here. We can do this. We can replace cos squared x with 1 minus sine squared x. And then we can also do the same thing here and replace sine squared x with 1 minus cos squared x. Let me just show you that part. Right here we can do this. We can say 1 plus, this is 2 sine x cos x. We've changed this to 2 sine x cos x. Then plus sine squared x, then minus. We're going to change cos squared x to 1 minus sine squared x. Becomes 1 minus sine squared x. Right? All this over 1 plus 2 sine x cos x. And then plus, remember this is cos squared x minus sine squared x. Is one of the identities. So it's cos squared x minus sine squared x. We're going to change this and replace it with 1 minus cos squared x. Right, let's just do that. Sorry, is equal to tan x. The right hand side. So it becomes 1 plus 2 sine x cos x plus sine squared x. Let's remove the bracket here. Becomes minus 1 plus sine squared x. All this over 1 plus 2 sine x cos x plus, let's remove the bracket, does not change anything, cos squared x minus sine squared x. Then we're going to replace this with 1 minus cos squared x. But let's deal with the numerator. 1 minus 1 is 0. Then sine squared x plus sine squared x is 2 sine squared x. So we have 2 sine squared x plus 2 sine x cos x over, so this is equal to tan x, right, over 1 plus 2 sine x cos x plus cos squared x minus, and then you can put this in the bracket, 1 minus cos squared x is equal to tan x. Okay, this, the numerator is already simplified, so we have the left hand side and the right hand side. So it's going to be 2 sine squared x plus 2 sine x cos x. All this over. Then let's remove the bracket here. It's going to be 1 plus 2 sine x cos x plus cos squared x minus 1 plus, because of the distribution of negative 1, plus cos squared x is equal to tan x. Right, 1 minus 1 is 0. Cos squared x plus cos squared x is 2 cos squared x. So we have 2 sine squared x plus 2 sine x cos x over these two. They give us 2 cos squared x plus 2 sine x cos x is equal to tan x. In the numerator, you can factor out 2 sine x. So it's 2 sine x. Then 2 sine squared x divided by 2 sine x, we get sine x. Then plus 2 sine x cos x divided by 2 sine x is cos x. Right, over, here's common factor, here is 2 cos x. 2 cos squared x divided by 2 cos x, that is cos x. Then 2 sine x cos x divided by 2 cos x, we remain with sine x. Then this bracket, they're just the same. Sine x plus cos x is just the same as cos x plus sine x. Addition is commutative. So this bracket divided by this bracket will remain with 1. Then means 2 sine x over 2 cos x is equal to tan x. 2 divided by 2 is 1. Sine x divided by cos x is tan x is equal to tan x. So we have proved that the left hand side is equal to the right hand side.